Hello everyone, welcome to my channel Learn Maths with Trisha. So today we are starting with the second part of the important sums of cones and cylinders. So without wasting a time, let's dive into our topic. So the sum says there is a wooden capsule made out of a cylinder and two hemispheres on the other side. Now we need to find the sum and TSA of three parts. Okay. Given the radius of the capsule is 3.5 and length of the cylindrical block is 14 centimeter. Now we know radius of the cylinder, that is the radius of the hemisphere, which is 3.5, and height of the cylinder is 14. Now total surface area of the cylinder, this is the formula, and total surface area of the hemisphere, this is the formula. Now entire total surface area is total surface area of the cylinder as well as these two hemispheres. So we are just writing it. Now we are just substituting the formulas, and it is 2 into the TSA of the two hemispheres because there are two hemispheres. Substituting everything and we are getting 2 pi r. Now we are just putting the values in each of the given letters, and we are getting 616 centimeter square, that is the total surface area. Now the eighth sum, the surface area of solid metallic sphere is 2464 centimeter. So it is given surface area of solid metallic sphere is this. It is melted and recast into a solid circular cone with radius 3.5 and height centimeter. We need to find the radius of the sphere and number of the cones that recast means number of cones that are made from that sphere. So the radius of the sphere is r. Now surface area of the solid sphere. So we are putting the value and this. From here we get the capital R. That is the solid radius of the solid metallic sphere. We are substituting the values and getting R as 14 centimeter. Now to find how many number of cones that are formed. So first we are taking radius of the cone and height that is provided. Number of cones that needs to be formed is n. Now sphere is melted to form cone. So volume of the sphere is equal to n number into number of volume of cone. Putting the formulas, substituting it, and we are getting n as 128. Ninth sum, a tent is in the shape of a cylinder surmounted by a conical top. So this is the figure. If the height and radius of the cylindrical part are 7 meter each and the total height of the tent is 14 meter, find A, the quantity of air inside the tent, and B, radius of the sphere whose volume is equal to the quantity of the air inside the tent. Now first radius of the cylindrical part is equal to the radius of the conical part, that is 7 meters. Now height of the cylindrical part, that is capital H, is 7 meters again. Height of the conical, that is small h, that is 14 minus of h, so we get 7 again. Now quantity of air inside the tent is equal to volume of the cylindrical part plus volume of the conical, because see this, if this is the figure, air is completely filled inside, so it is this cylinder plus cone. We are just putting the values and substituting it, we get it as 1437.33 meter cube. Now for the second part, so radius of the required sphere will be r. So volume of the sphere is equal to quantity of air inside the tent. So we are considering 4 pi r cube volume of the sphere plus pi r square h plus 1 by 3 pi r square h. So we are just substituting and we are getting r cube, and we are getting that as 343. Now r is 7 meters. Now the 10th sum, a solid cone of r that is given as 5 and h 9, h is the height, is melted and made into small cylinders of radius 0.5 and height 1.5. Find the number of cylinders formed. So number of cylinder we are taking as n, then radius of the cone and height we are taking in capital. So capital R is 5 and capital H is 9, and cylinders, that will be, because it is small into small cylinders, so small r and small h, that is 0.5 and 1.5. Now cone is melted to form n number of cylinder, that means volume of the cone into is equal to n into volume of sphere. We have just seen this case similar just before this sum. So we are just substituting, just writing the formula, substituting each of the values and finding out, just simplifying and substituting everything, we are finding n is equal to 200. Now for the 11th sum, a hollow sphere of external diameter 10, so this completely is 10 and internal diameter is 6, is melted and made into a solid right circular cone of height 8. Find the radius of the cone formed. Now external radius and internal radius of a hollow sphere, we are taking capital R and small r, that is 5 and 3 centimeter. Again height of the cone is 8. So now volume of the metal in hollow sphere is V, that is equal to 4 by 3 pi bracket capital R cube minus small r cube. Then volume of the sphere is 4 by 3 pi. We are just putting the values of the radius and we are getting it as 392 by 3 pi. Again now volume of the cone is 1 by 3 pi r square h and number of cones formed is m. So volume of cone is 1 by 3 pi m square into 8. Now we know the sphere is melted to form cone, thus volume remaining the same. So we are just putting 392 pi is equal to 8 by 3 pi m square. We are just equating both of the equation, then getting equating both of the equation to get m, that is the number of cones that needs to be formed. Now substituting, putting the values, we are getting m square, that is 49 and m to be as 7. Now for the 12th sum, it says there is a tilted right circular cylinder vessel with the diameter base 7 centimeter, contains a liquid. When placed vertically, the height of the liquid in the vessel in the mean of the two heights shown in the figure. Find the area of wet surface area when the cylinder is placed vertically on horizontal surface. So this is the particular diagram and the liquid is inside of it. So when vertically placed, the height of the liquid H, that is 6 plus 1, that is 7 by 2. Now diameter is 7, so radius will be 7 by 2. Area of the wet surface, that means the touching part, that is pi r square plus 2 pi r h. Substituting each of the values and getting 115.5 centimeter square. Now the 13th sum, which says oil is stored in the spherical vessel occupying 3 by 4 of its full capacity. Radius of the spherical vessel is 28 centimeter. This oil is then poured into a cylindrical vessel with radius of 21 centimeter. Find the height of the oil in the cylindrical vessel. So this is the figure. Now radius of the spherical vessel is 28. Volume of the spherical vessel V, that is 4 by 3 pi r cube. Volume of the oil inside it is 3 by 4 V. So now again the radius of the cylinder is capital R and height of the oil is H. So 3 by 4 V. So we are substituting the values of V and we are getting 22 by 7 into 28 cube. Again volume of the oil is equal to the volume of the cylinder up to which oil is filled, pi r capital R square H, that is this value, this is the value, and we are substituting the value for H and we are getting H as 28 cube by 21 cube, and substituting it we are getting nearly equal to 50 centimeter. So with this we are done with this chapter. All the important sums are covered in the 2 videos particularly for this chapter. So do like, share and subscribe and stay tuned in for more important such sums that is going to come up in my channel, and thank you so much for watching.